All right, welcome to class. Our focus for today's class is going to be on the motion of objects under gravity. Okay, in some textbooks or in some authors decide to call it motion under the free fall. So both cases are the same. They're talking about the same thing. All right, the first thing we have to note is, what is gravity? Number one thing is that gravity is a force. That's the first thing you have to note, is that gravity is a force. And this force tends to pull objects towards the center of the earth. Okay? The first thing is that gravity is a force, and it tends to pull all objects towards the center of the earth. So the vertical fall of all unsupported objects, please take note, vertical force, okay, that tends to pull all unsupported objects. And these unsupported objects are pulled, okay, are pulled towards the surface of the earth, towards the surface, towards the surface of the earth. Okay, it is a first vertical force of all unsupported objects that pulls the object towards the surface of the earth at a constant acceleration due to gravity. Okay, all these while neglecting air resistance is termed the motion under free fall. Okay, when all these are pulled into consideration, okay, it is a vertical force which acts on all unsupported objects that tends to move them or push them towards the surface of the earth at a constant acceleration due to gravity, described a particular concept known as the free fall. Okay, so that is actually what free fall is all about. The next thing I would like you to understand or to note is, how can we describe this motion under free fall? Okay, how can we adequately explain the motion? We have to consider or take note of the following notes. The first thing you have to take note is that the acceleration due to gravity G, is positive when an object is acting downwards. Okay, acceleration due to gravity becomes positive when an object is moving downwards. That is, when the object is acting in line with gravity. All right, so for a downward motion, the acceleration due to gravity is always positive. All right, and that is why if you're coming down the stairs, it is relatively easier, okay, because you are acting in line with gravity. The next case is when G is negative. When acceleration due to gravity is negative, then the object or the motion of the object is acting upward. So it describes upward motion. Of course, using the stairs or the staircase as an illustration, you realize that you expend some energy, or it is relatively difficult, okay, to ascend a hill, because at that point you are working against gravity. Okay, if you're climbing the stairs, realize that the energy you use to come down is not the same energy you used to climb. Of course, the energy you used to climb will be higher than that which you use to come down, okay? And the reason is because of the force of gravity, all right? Now, the third case I would like you to consider is that if an object is dropped from a particular height, let's say h, okay? The object is dropped from a particular height h, the initial velocity of the object is equal to 0. So when an object is dropped from an height, the initial velocity u is equal to 0. I'm sure you understand that already from our previous knowledge on acceleration, velocity, and speed. All right. Now, the fourth scenario I would like you to consider is that if the object is thrown upwards, if the same object, let's consider this pen as the object. If I decide to throw this object upwards, okay, the final velocity at the maximum height, the final velocity at, let's say this is the maximum height, the final velocity at this height is equal to 0, okay, because at that point the velocity becomes 0 momentarily before coming down. Okay, so the final velocity v is equal to 0 at maximum height when the object is thrown upwards. Okay, so we can explain the motion of this object using some equations, just like we have the equation of uniformly accelerated motion. In this case, we are not going to derive the equations again. I will just tell you some parameters to change so as to obtain the equations under the free fall. All right, and we have to note that while considering free fall motion, okay, while considering free fall motion, the equations, now we have that the equations are derived by replacing, okay, by replacing the linear acceleration with the constant acceleration due to gravity, okay. So a becomes g, all right, a becomes g, and in this case becomes negative g. S becomes h, all right, s becomes h, while other parameters still remains the same. So for the first equation of motion under free fall, we have that v equals u plus minus g t, all right, as against the conventional one we know, the linear motion, which is v equals u plus at. Remember, I said a will be replaced with minus g. So if you open the bracket, you have that v is equal to u minus gt, and that is the first equation under the free fall, right? The second equation is just like its counterpart under the linear motion, which is s equals ut plus half at squared. And bearing in mind that g equals a equals minus g and h equals s, so we can say that h is equal to ut, okay, plus 1 over 2 minus g t squared. All right, so if we simplify further, rather, you have that h is equal to ut minus 1 over 2 gt squared, and this is the second equation under free fall. Right, the third equation is just like its counterpart under the linear motion, where we have v squared equals u squared plus 2as, still bearing in mind that s is equal to h and a equals minus g. So we have v squared equals u squared plus 2 into minus gh. I will simplify further to give u squared plus, minus 2gh. This is seen as the third equation, and these are the major equations, the three basic equations on the free fall. So let me highlight them in one slide. We have v equals u minus gt, we have h equals ut minus half gt squared, and we have v squared equals u squared minus 2gh as the equation 1, equation 2, and equation 3. The other equations are h equals u plus v all over 2 into t. And we also have h equals vt plus half gt squared. So we can decide to call this equation 4 and equation 5. But mind you, these are the three basic equations we use under the free fall. With this, I am super excited to announce to you that we have come to the end of the class on the motion under gravity. And I'm sure by now you have understood the concept of the motion under gravity. But in case you have questions, kindly drop them on the platform. And our able instructors, of course, will be there to attend to you. So see you in our next class, where we will continue our topic or our discussion under the concept of motion. See you, we'll meet again. Bye.